All right, let's go on to look at question 2, where you have your naturally occurring oxygen with the three isotopes 16, 17, and 18. Okay, so those are your masses for the three different isotopes. The most common one will be the one with mass 16. Okay, so they want you to show that the relative atomic mass is 16. Okay, so basically what you want to do, right? You want to take the percentage multiplied by the three isotopic masses, and then you add them up, okay, according to their percentages. So even if we add up the three, right, you realize that when you round it off to 3 sig fig, it will be 16.0. The 17 and the 18, because they are found in such small percentage of relative abundance, they don't actually figure in the final AR. Okay, part B, figure 2.2 shows an experimental setup to investigate percentage of oxygen in the air, which is roughly about 21%, right? Okay, so they pass 50 cm cube of air over copper wire. So this was the 50 cm cube. At the end of the experiment, right, the volume remaining is 39.5 cm cube, which is what we expect, right? That is about 79%. Prove that the percentage of oxygen is 21%. So you just take 50 minus 39.5 over 50 times 100%. That will show you that is 21%, because the rest, right, which is the 10.5%, was used in a to oxidize your copper to copper oxide. Okay, so this was the reaction that happened. Copper plus O2 to give you CuO, copper oxide. Okay, so this was where the 10.5 cm cube went to. Okay, so we have boiling point of argon, nitrogen, oxygen. So they show you a fractionating column. On figure 2.4, identify the gases X, Y, and Z. Okay, using data in table 2.3. So basically, right, X will be the gas that actually what do you call it? X will be the gas that boils off the fastest, so that will be the lowest. At the lowest temperature, it changed to gaseous upon heating. Right? So you want to choose the temperature which is the lowest, and then it will be boiled off the fastest. Okay, then of course the second one will followed by your argon, and then your oxygen, which will be the last to boil off, to vaporize. Okay, so part 2 says during separation process, the mixture of argon, nitrogen, and oxygen allowed to cool from room temperature to minus 200 and cooler. Which substance will turn to liquid first? Okay, so basically you want to this is from a higher temperature, is allowed to cool ma. Okay, so we go from like maybe negative 180 degrees Celsius, we cool it down to negative 200 degrees Celsius. Okay, so which one will turn into liquid state first? So you want the smallest number here, which will be oxygen, right? Because as soon as it drops down to minus 182 degrees Celsius, oxygen starts to go from gaseous to liquid. Okay, because it has the highest melting point.